Hi everyone. All right. Okay, can you hear me? Is this good? Okay. All right. Hi everyone. I'm James Houghton. I work for Google. I work on live migration. That's what I guess I've been doing for a few years now.
Really close.
Okay.
Not our fault.
All right. And thanks everyone for coming. I'm going to talk about how we can potentially do post-copy live migration with guest MMFD, or at least what I think is required.
Sorry.
Okay. Man. Okay. Okay. Okay.
No way.
Okay. So
Code
this,
of
I'll
conduct
try to
alert.
stay still. So this is good. Everyone can hear me? This is good?
Talk really loud.
Okay. I'll try to talk really loud. Okay. So thanks, everyone. So today, what I want to get out of this is to review the scope of KVM user fault, which is this solution that, the missing piece that I think we need, so what it should do, what it shouldn't do. And ideally settle on a good user space API for this KVM user fault thing. And just before I say anything else, KVM user fault is different than user fault FD. User fault FD is for main MM, if you're conventional mem slots that you're not using guest memfd. That's how you do post copy, at least with an upstream kernel. But KVM user fault is separate, and it's what I think we need something like that for guest memfd. And so if we get to it, I want to talk about guest memfd's interaction with user fault FD. On top of KVM user fault. Okay, so this is the problem that Google has anyway. We need to support post-copy for memory encrypted VMs. We today already support it for SEV VMs, but we want to support it for SEV SMP and for TDX. We want to support post-copy for regular VMs, so non-memory encrypted VMs that use guest memfd. When the time comes that we want gig pages or something, not with UCL BFS, but straight through guest memfd. That'll be important. And we need whatever post-copy solution we end up with to scale to a ton of vCPUs, like 400 plus. And so I want to spend a little bit of time talking about how sort of you can do post-copy today with just messing around with memory attributes for memory encrypted VMs. So you could just have everything be not private, so all shared to begin with, and then when you get guest private faults on it will come out to user space because of the attribute mismatch, and we can, then we can fetch the correct page, switch it to private, and then we're good. And then for shared faults, everything's just shared, and you can just use user fault FD like that, like a conventional VM. Now, the reason that this is the main reason that this kind of sucks is that we have to take 2 locks when doing memory attribute conversion, which is, doesn't scale to 400 plus CPUs. When all of the vCPUs are independently doing post copy. And it's done with an X array, so there's dynamic allocation in there. So yeah, that doesn't work very well. Maybe it could be solvable, but it'd be hard. So, and then for non-memory encrypted VMs, like say you're using the KVM x86 software protected VM, whether or not a fault is guest private or not just comes down to what the memory attribute is. So if you leave everything as shared, everything's just going to be shared. You're never going to, you could switch it to private after post copy is done, I suppose. I'm honestly not really sure.
After pre-copy is done.
After post copy is done. Like after the entire migration is completed.
Okay.
Which, maybe you could do that, but that ideally, all the memory attributes should just be what they should be. So like if the guest has said, all of this is private and all of this is shared, we leave it like that. That avoids performance issues with locks and stuff like that. Okay, so if we don't have this hacky way of doing it, what do we actually need to do post copy? So if we just assume guest memfd is mappable and can be faulted in user space, we don't really have to assume that. But that means that shared accesses to guest memfd will go through user space KVM's own non-guest accesses to guest memfd. We'll just use the user space page tables, and we can use user fault FD. We can talk about that later. Yes.
So we kind of can't, because we're just having the conversation in the previous session of not going through the user space page tables. So that throws a wrinkle in things.
Okay.
Which makes me really sad, but I think we do need to talk about it.
Okay, in that case, KVM user fault can be extended to include, so instead of doing normal U access, you do something bespoke. You could extend KVM user fault to also catch those. That's in fact what the latest version of KVM user fault on the mailing list does, kind of. So we could do that, but let's at least agree on the more basic thing that KVM user fault absolutely must do, which is prevent the guest from accessing guest private memory. Because that's just going to go straight to guest memfd. There's no question about that. That's what guest memfd is for. And it's not going through gup, so there's no user fault fd, and so there is no mechanism currently to intercept those accesses. So we absolutely need that. I don't think that's controversial. And that's what KVM user fault is for. For guest accesses to non-private guest memory, I'm not sure what the plan is. My understanding is that we won't go through the user space page tables. Okay, great. In which case, KVM user fault is even more useful. If we did go through the user space page tables, we could maybe use user fault fd in that case too, but it doesn't really matter for the sake of KVM user fault. Okay, so KVM user fault is an API to prevent KVM, or prevent the guest from accessing whatever memory, like whatever guest memory. Essentially, it's to give user space control over the EPT. So if user space says this memory is user fault, the stage 2 is not allowed to map it, which prevents the guest from accessing it. And that allows us to prevent the guest from accessing guest private memory. That's what we need. Now this, I was just saying, I know Sean, you were saying this might not work, but I was saying this, so in my head, what is needed is just that. We just need to prevent guest accesses. We don't need to prevent KVM's own accesses to guest memory, because those can just use user fault fd if they're going through user space page tables. Now I guess that might change depending on if we don't go through the user space page tables in that case. And also in my head, whether or not a page is user fault or not is a property of the mem slot. I suppose that comes down to what the UAPI should be. But maybe the mem slot or maybe something else. But like if you had a bitmap for a mem slot where we had just described for every page in the mem slot, is it user fault or not? This is kind of what I have in mind for potential UAPI. So we have a mem slot flag, and when the mem slot flag is enabled, all the faults, like all the stage 2 mappings that are newly created will only be page size and can't be any larger. I guess that's the simplest thing. You could do something a little bit more complicated. And so for each mem slot, there's a bitmap. So for this, I don't think there's any reason to use memory attributes. I know I've already spoken about the performance challenges that come with using memory attributes. But given that user fault state is transient, memory is only going to be user fault for maybe a few minutes. Memory attributes seems like the wrong interface. Just having, if we use memory attributes, internally it's probably going to be a bitmap anyway. And so having the bitmap in user space, or maybe potentially not having a bitmap.
Yeah, so certainly you don't want to use the XArray for the reasons that you mentioned before.
Yeah.
So how would you initialize the bitmap, and how would you change the bitmap?
Yeah, so I think the simplest thing, if we do want a bitmap, is have user space allocate a bitmap that's at least as large as the number of pages in the map slot, has that number of bits, and then give a pointer to KVM, and KVM can just copy from user whenever it wants to check it. I think that's pretty simple.
And changes go through a Yocto.
No, if you, because unlike the dirty logs, KVM doesn't have to have atomic, from the user space perspective, atomic manipulation of it. KVM just needs to react to, can I fault this in or not? And so I think you can actually have user space own the entire thing, and KVM just gets a pointer, and anytime KVM accesses it, it's just a user access. Yeah.
The user has to be really careful to order the memory properly, so update the page, SMP, WMB, and then update the bitmap. So I guess user space has to be a little careful, but user space probably already has to be careful. Like our user space, and presumably QEMU as well, is all today must do that. Yeah. Okay, so I think that storing it in user space is a much better idea than storing it in KVM, because it saves even more interface changes that aren't really necessary, and saves having to do a syscall every time you want to allow the vCPU to now access the page that we've just fetched. Was there anything I missed on the last slide? Oh yeah. So when you get a fault on a user fault page, I'm just reusing the KVM exit memory fault stuff that already exists. Maybe set a new flag just to make it obvious to user space. And then yeah, user space does this thing. And then when we can collapse the pages or collapse the mappings, I mean, when the user fault or memslot flag is removed. I suppose we could add a new ioctl to be able to collapse things as we've fully populated everything, but I don't really see the need to do that right now. Yeah.
Actually, you could probably just reuse the pre-fault.
Oh yeah, that's
Because I
yeah, that's
think
good.
that would work if it happened to find the entire thing there and you didn't have the flag set, maybe? I don't know.
I mean, yeah, that's possible.
I think that if you really wanted to get granularity, KVM now has the fancy scalable mem slot stuff, so you could just create a metric ton of mem slots. And then you'd have granularity there if you wanted to. I don't know that's a good idea, but you could if you really cared about it.
I don't know if we really want a ton of mem slots like we.
Who doesn't love 32,000 mem slots?
That doesn't sound like a good idea.
So I first just want to understand your use case a little bit better here. So you've got shared and private memory, right? Which is, this is a Coco VM. How are you doing post-copy LM on a Coco VM anyway?
So, like, I guess the question is, how are you actually installing the memory? Like, how are you doing live migration?
Yeah, in a way, yes.
I mean, most of I guess at least for TDX, there's a spec defined for how it works. You go through the TDX module to install and uninstall pages. There's a state machine there. SNP is working, or SEV, SNP is working on their model as well. I'm not really sure how to answer a generic question here other than you can do it. You just have something that's more privileged that's doing the page installation and uninstallation.
Okay, but user space is responsible for copying the memory in. Is that correct? No.
Well, user space is responsible for doing whatever it takes to install the correct contents, presumably calling it to some TDX ioctl of some kind. Sorry. Yeah, but so user space is obviously for private memory. It can't just copy the contents directly in. For shared, it can.
The way I would put it is that the TDX or whatever secure infrastructure is doing enforcement on the state machine to ensure you're not making a mistake, whereas user space is kind of reacting and making decisions about what pages to install, at what point, tracking dirtiness from a accuracy and desire to move the pages perspective, but not from this security perspective.
I had more questions, but you go ahead.
So the way you actually physically get it, the secure whatever thingamabobber re-encrypts it with the transport key instead of the ephemeral key. That allows you to ship it over the wire to your destination, and then you reverse the process through APIs or magic instructions. But actually, for a lot of this, I think the confidential compute stuff I don't care about. It's more like if we want guest memfd to be a general purpose solution, we need something like this anyways. And then the other aspect of this is making user fault FD more scalable when you have 400 vCPUs so that you're not having to all shove them down the user fault FD path. And that's where the exit on missing stuff. So just we care about accelerating the guest page fault path, not so much the one-off accesses. And so that one you can also get through this. So the Coco stuff, it's like, okay, it's one of the motivations, but it's not, for me, the main motivation.
I'm still trying to understand how user fault FD is going to fit in here at all. Are you saying it's basically we're not going to use user fault FD, we're going to exit? And the reason I'm asking is because if you've got a whole bunch of vCPUs that all access the same address and fault, do you kick them all out to user space, and then you've got to do some user space song and dance coordination?
So
Yeah.
for private memory, yes. Like for guest private memory. For guest shared memory, I guess it depends on what KVM decides to do. But today, the behavior is always to go to GUP for guest shared memory, and so we would go to user fault FD in that case. And so that's where user fault FD comes into it.
Well, but not if we have this, though. If we have a bitmap that can say guest cannot access this, you hit a page fault, and then you punt out to user space. And from
Sorry,
Unless someone has very, 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 very good evidence that we have to keep it in KVM for performance reasons, just if you hit it, everything goes out.
So that's a good point. So this would break. So Sean is right. So for all guest faults, even shared ones, would come out. KVM zone X's and other things that use the user space page tables won't, obviously, because it's not the VCPU run Octal. But yes, it would break async page faults because the vCPU thread is no longer, it can't be running because it's out in user space. And so I suppose if you cared, all we really need is for guest private faults to come out to user space. But guest shared faults could go to GUP and then you could try to rerun things. But yeah.
Conceptually, if we want to solve the async page fault case, we could do something similar to, the dirty ring, where you have a ring buffer of some kind, and you tell user space, your guest tried to access this, and you essentially do async page fault, but you pipe it out to user space. Yeah, okay, that's a different beast.
Yeah, I also thought that was a good idea.
But I do think, though, it's worth noting that if someone wants async page fault support on top of this, I don't think it will fundamentally change what we want to do for making the user fault case scalable to 400 or whatever vCPUs.
I think the user fault FD scalability is a problem. And I wonder, from this conversation, what are we saying? That we're kind of giving up on user fault FD and doing stuff in KVM to make post-copy LM scalable? Shouldn't we be saying, how do we make user fault FD scalable? Per task structs, get better locking. Yeah, I don't know. Shouldn't we be trying to do that?
I think KVM user fault is a nice, it's a nice optimization that this gives user fault FD live migration, but I think KVM user fault is just necessary anyway to support live migration with guest memFD. So I don't really see it as us giving up on user fault FD, but
I mean, we did give up on user fault FD because there was a whole conversation long between Anish Murthy and Peter Zhu about, do we do something in KVM versus do we do something with user fault to make user fault more scalable? And it came down to, it's so simple to do it in KVM modulo the async page fault stuff that it was like, why not do the super simple thing, especially when you get to guest memFD where you don't have the user space page tables and you can't do user fault FD, and like James said, you need something anyways, and it's simple enough, why not do it?
I think the hard thing, I thought about how to make user fault FD faster and came to this conclusion and then had Anish work on it for me. I came to the conclusion that you probably want something like a lock-free wait queue. And I tried to do that and I was like, this is a terrible hack.
So
but maybe someone
or
more
per
confident.
vCPU. Yeah.
Maybe. That's also kind of difficult, but doable, I suppose.
If I understand this correctly, what you're basically doing is you're effectively causing an exit from exactly that vCPU context into user space to handle the fault, right? Which is sensible. Now, depending on your VMM, some VMMs like Firecracker completely depend on the model of user fault FD that you can have a completely different process handle your faults than the VMM. So they completely separate these into different entities. And the thing that handles your live migration, in that case mostly snapshot restore, doesn't even live inside, doesn't have access to KVM things. Would you expect that would just be a communication channel you do in user space, which would be dock slow, I suppose? Or how would we, do we care?
So I think what you're doing is solid work, but as we discussed offline before that, we're trying to make stuff work in a certain way, maybe that shouldn't be working that way. I mentioned at some point that maybe you want a user fault FD-like mechanism, but on the guest memFD, meaning whoever accesses it, if it's a fault that gets triggered, if it's KVM that accesses it, you have a similar mechanism where you could poll on an FD, you could register in file ranges, something like that. The same scalability issues probably would arise, but I mean, at least they would be the same.
So you could do that, but it's just more complicated than, I guess, the API I've proposed. Like, you don't need to have like a poll mechanism so that a separate MM or sub-process can do post-copy for you or do like restoring from a snapshot for you. You can always add that if it's a really important use case, if you're using guest MFD with that. I don't see why you can't have both. I mean, we almost had both because, I mean, the cap exit on missing likely would have been merged if we didn't think that KVM user fault was also something that was going to be merged as well. So.
Two things. I think we are going to need it again if we don't do the user mappings for KVM's accesses. We're going to need something that along the lines of what David said. And then for the Firecracker case where the priority is to handle the post-copy stuff in a different process and you want async page fault, I don't think you're running 400 vCPU Firecracker VMs, so just don't enable this. I think that's really the answer is for guest memfd, but if you solve the problem with guest memfd where you have something that's like user fault, you don't have the same performance concerns. So I think they're orthogonal, and again, that's why I say like I don't really care about the Cocoa use case too much. It's more the scalable aspect of this that I think is more useful and do it in a generic way. And then it still has the guest memfd problem that you need to solve, but orthogonal.
You say that you don't care right now about Cocoa VMs, but somewhere like migration would come there. So,
well, maybe not. I don't say that sorry, I shouldn't say that I don't care. That's not my motivation for pushing this along. And I don't want to fixate that this is only for Cocoa VMs. That's what I should say. Not that I don't care, but that there are a lot of other use cases for this beyond just Cocoa.
So some of the detail. I just wanted to have a question on what you just said, David. You said you were suggesting UFFD style API for guest memfd specifically. One idea I had at some point, which just might be complete nonsense. What if we don't have a specific for guest memfd, but for arbitrary FDs? Because one more use case I could see for that would be post-copy migration for vhost user devices, where now you have, say you have traditional memfd-based guest memory, and now you map it into multiple processes, and then multiple processes map, and because UFFD is VMA-based, you have multiple UFFDs, and that's a huge mess. But if it was just working on the memfd, then that entire problem would also just go away.
So David and I have talked about that a little bit. I think maybe it could work, but right now it would totally not work with how we use user fault FD at Google anyway. So today we rely on having two mappings of guest memory, so say one file. One of them has user fault FD enabled, and we give it to KVM, and that's how we get user faults and everything. The other one, well, we have to somehow get the memory into the file. So we have a second one that we then give to our device that fetches our memory, and it gups the page. And if we tried to give it the user fault FD one, gup will just sit there, and it'll have given us a user fault. And so if you try to move that to the file, then all of your mappings would be user fault, and I'm not really sure how you'd get at the page cache at that point.
Right, the basic question is like, how can you get something like the continue user fault FDIO continue
Exactly.
in the same model? I assume it could be solved in a way, but it's not as straightforward.
Yeah,
So
I mean,
if you want to do DMA to the page before you have it in a page cache, or you want to have it in a page cache but have a way to still get notified if somebody accesses it, I think it can be done. We should probably get Willy involved at some point if we're going down that road. But yeah, it is more complicated, but to me it sounds like the right thing to do.
I suppose.
It's all nice what you're doing, and I see how you ended up there, because like you were running out of options. But as soon as you mention, yeah, we're going to mix user fault FD and the other one, and I'm like, okay, like now we're trying to combine all of the complicated pieces to form something complicated. I see how you ended up there, and I'm not saying it's bad. I'm just saying maybe there is an alternative. Maybe it's an alternative for the future. Doesn't mean that like your stuff is not.
I've thought about that like for a while. I haven't come up with a good solution for how to make like a file-based user fault FD. And I think no matter, like, it would be kind of complicated to do it, I suppose.
I mean, the first challenge is finding a name because userfold now it's not like.
Yeah. But I mean, yeah, I still think it's a good idea to start with something like KVM user faults. I guess I need to understand a little bit more if it really is required to have like a polling mechanism, like if KVM's own access to guest memory need not to go through user space page tables. But yeah, so I guess I'm curious if you guys think that it really is necessary to figure out if a file-based user fault FD would, like, definitively, is it not possible for sure? Like, is it actually incompatible with post copy for our use case? Like because I think it would be, like in my head. So anyway, so does that block KVM user fault? Does that block emerging KVM user fault?
I don't think so.
Okay.
Yeah, I also don't see. I mean, you would put the task into the block queue. You would send a message up that says this file offset is missing. User space resolves it, says resume anything waiting on this file offset. I don't see the issue.
Then, well, you have to somehow.
Maybe you need a magic mmap flag. Everybody loves mmap flags that says, well, like, I'm special, I can map this without notification. Something very stupid, but where you could get your DMA and your userfold FDI continue alternative. I'm not saying there might be ways, I haven't explored them all, but maybe we should explore them.
You need to have some way of, like, upon resuming whatever was blocked, that it won't block again. Like, for example, if we wanted guest memfd to participate with user fault FD, because I'm like, so say KVM, say we can mmap guest memfd and KVM uses it when accessing guest memory, like when doing U-access. I've been saying that, oh, you could use user fault FD for it, but it wouldn't work out of the box. So in this case, like MM would call VMOps fault, and conventionally, like normal user fault FD today, with Shemem and HUGHTON and Anon, well, I guess Shemem and HUGHTON in this case, VMOps fault contains, like Shum fault, contains user fault FD stuff. It would really suck to do that with guest memfd. But so, I guess tying this back to what you were saying. So in this case, we get a fault, and to resolve it, we basically, we have to install the page table entry, and I guess having a gup flag, so like calling gup with a flag that says, okay, ignore this user fault stuff before calling fault.
It's like the mmap flag.
Yeah, basically. I don't really know how this would apply to files. Like, this is what I mean. You need something like this.
Yeah, the file fault handler can call into user fault FD itself. If it sees the data is missing, it can sleep itself, basically. I'm not sure if that's what you meant.
That makes sense. Yeah. It can. Like the file system fault handler.
Exactly. So KVM tries to get the PFN from guest memfd. Guest memfd sees that it's not currently there, and it can call into user fault FD and sleep
so then
itself.
To resolve that, you basically have to install an EPT mapping at that
exactly.
point.
And that could retry, and then if it faults again, it just does the same thing. But if the EPT has been set up, then it continues running.
I guess you could try to do that, I suppose. But
Two things to your question of should all of this stuff block the basic exit on missing functionality, I think the answer is no, because again, I think they're orthogonal things. The wrinkle with that is if it's the page fault emulation path, that's again under spin lock, you can't block, and you probably don't have a priori knowledge of which pages that you want to access, especially in a nested scenario, and it's just sad. So, and it's again, I think why we should probably separate these things, because supporting user fault FD-like semantics on guest memfd, if we're not doing mmap on guest memfd, is going to be a much harder problem to solve.
You would probably need some kind of like two hooks, like one, like a call to user fault FD, but also a custom implementation of UFFD copy or whatever it's called. But I'm not sure I'm so worried about the page fault path because you would just do it multiple times. Like the first time you install, you go back, you get a second user fault of default, then a third until everything is so, like, worst case, it's 4 plus the actual page until it's resolved. So that shouldn't be a problem. Like, conceptually, maybe I'm on old school KVM where everything should be done with regular kernel stuff and KVM just happens to use it. I like the idea that that you can do that, especially for shared pages. This API I do like. I very much prefer it to the exit on missing one though.
I guess, well, we're out of time. But so thanks everyone. This is a really helpful discussion. I was hoping that it would end up.